Hi, everyone. Welcome to Tom Raftery TV. And with me on the show today, I have my special guest, Bilal. Bilal, welcome to the show. Would you like to introduce yourself?
Thank you very much for having me, Tom. Absolutely. As you mentioned, my name is Bilal Khursheed. I am the worldwide leader for power and utilities at Microsoft. And I get the opportunity to work with power utility companies globally around their digitalization and technology strategies to really accelerate their core objectives and also achieve the energy transition.
Okay. And how did you land that role?
I'm a utility guy through and throughout. My fascination with technology combined with my experience in the utility industry, I think was a good fit for this particular role. And knowing that such a significant shift happening across the entire industry when it comes to the mass adoption of kind of bleeding edge, cutting edge technologies that are underpinned with cloud and AI, having the opportunity to be with a leading organization like Microsoft to deliver real change, real impact, and real value for an industry that's going through so much change, that was a fantastic opportunity, and I'm privileged to be here.
Sure. And you are a utilities guy. You worked with Hydro One, wasn't it?
That's right. My background is in the utility sector. I was with Hydro One for just over 14 years in multiple aspects of operations within transmission and distribution. Also spent some time in nuclear early on in my career as well.
Very good. And could you describe the current state of the industry now? I mean, you alluded to their changes that are happening, but give us a brief rundown on where you see the state of the industry right now.
Yeah, absolutely. I mean, I think ultimately when we think about it, is that the utility industry, foundationally speaking, was built around stability. And I think what you're seeing now is that the days of stability for the industry are really far behind us. There was a lot of predictability when it came to supply and demand. And largely speaking, the utility business model hasn't really evolved in 60, 70 years or so. And that really began to change about 15 years ago. Everything from the way power is being generated, the way it's being distributed, the way it's being bought and sold. We're really seeing that fundamental shift as to how we generate and distribute power. And of course, I mean, there's a few drivers behind that around technology specifically that's evolved. And of course, the other is climate change. There is a need to be more sustainable going forward. And through that, we're seeing the industry move away from these massive kind of centralized power stations to a much more distributed dynamic grid, thinking about things like rooftop solar, local battery storage, wind farms. You have all of these sources that are now much more closer to where the load is and where the power is actually being consumed. So some pretty significant challenges that this presents. Ultimately, the our power grid wasn't designed for this.
Mhm.
And the industry is really adapting to this kind of two-way traffic when it comes to power, where your traditional consumers now can actually produce energy back and produce it back to the grid. And adjusting for this is a big task for the industry. We're talking about significant infrastructure upgrades. We're talking about changes to regulations, complete shifts in terms of how we think about managing energy.
Yeah.
And the good news is that we're on our way. It's something that gets me quite excited working in the industry because we are in midst of a pretty major transformation, a revolution of sorts, really, that's happening right now. And it's a thrilling time to be part of the journey.
Sure. And we had a big change here in Europe as well over the last couple of decades with a shift to a far more deregulated marketplace. That's got to be a big change as well, no?
Absolutely. I mean, deregulation is driving a lot more competition. It's changing your traditional utility models.
Mm.
It's driving so much more reform within the traditional utility and also the external stakeholders. A lot more on that front needs to be done. But I think when you think about technology specifically and how we can accelerate and accommodate for some of the changes that's presenting, it's quite interesting to see how things need to be woven together in order to deliver those outcomes that we're looking to achieve.
Sure. And is cloud playing a big part in this, do you think?
Absolutely. Utilities are under immense pressure, right? Immense pressure to do more with less. There's a big push to drive down operational costs across the entire value chain. You have capital work programs that are growing substantially, like I mentioned, around the infrastructure upgrades. You have the need to integrate renewables and, of course, the entire aging infrastructure as well.
Mm.
And the other element to it is that you have the workforce within the utility industry is experiencing significant retirements. So, these utility organizations are being asked to meet these growing demands with fewer resources, ensure higher degrees of reliability, sustainability, and cost efficiency. And to me, this really boils down to, how do we better understand the tools and technologies that we need to have in place to build that energy infrastructure of the future? Because ultimately, the tools and solutions of yesterday aren't going to build the energy system that we need to build for tomorrow. And really, the cloud is kind of that underlying capability that's going to unlock this. You have so much data that now needs to be collected, needs to be contextualized, action against, and in many cases, this needs to be done in real time. You have a growing number of things like edge devices.
Mhm.
You have line sensors, smart meters, for example, that are producing data points traditionally every 15 minutes, but now to 5 minutes, to single minute, even sub-second intervals. So you're talking about a significant amount of data, and utility operators need to get to the right level of situational awareness as to what's happening on the network, and that's going to be done through the cloud. Your traditional on-premise infrastructure is just not capable of taking all of that vast data, aggregated it in real time, contextualizing it with other data sources like weather data, past historical data, even other asset data, and producing those outcomes that are needed to drive operational efficiency, to drive cost reductions, and achieve more sustainable business outcomes as well.
I remember back in around 2014, I was an industry analyst and I was attending the SAP for Utilities event in Berlin. And I remember remarking to James McClelland, who was the global marketing manager for SAP Utilities at the time, they had just at that event introduced their first Cloud for Utilities product. And I remember leaving the event with James and remarking to him, saying, within 10 years, all utilities will be 100% all in on cloud. And here we are 10 years later, and we're still talking about it as something that's just coming on stream now. So, where are utilities on that journey? Does it depend on region, or does it depend on utility size, or does it depend on leadership of the organization? Or, what are the factors that make utilities move to cloud before others, or where are they on that journey?
Yeah, it's a great question, and it's a complicated one to unpack. And because, like you said, there's regional elements that need to be taken into consideration. There are leadership aspects within each of the utilities that kind of will determine the rate of adoption when it comes to cloud technologies. There's some institutional assumptions when it comes to what cloud can do, like what it can't do, and interpretations of regulatory regulations, regulatory compliance aspects that may inhibit or slow down the adoption of cloud. So really, you kind of see some utilities who are very much cloud forward and have taken a very bold approach as to migrating some of their core aspects, going beyond just the IT infrastructure and ERP infrastructure, looking at more around the grid specific and OT specific tools. And I think the perspective that's widely shared is that is the right approach, because we need to look at what the cloud is going to unlock across operations for utility. How are we going to unlock higher degrees of reliability and resilience and drive higher degrees of employee engagement, of customer satisfaction and customer engagement with the utility customer base? And certain technologies will operate much better in the cloud, or can only operate in the cloud versus on-premise infrastructure. You think about digital twins. Predictive maintenance is something that's been used quite
Mm.
heavily over the last 10 years and continuing to. But your sophisticated AI models, for instance, how do we go from being reactive when assets fail to being proactive and anticipating where equipment failures might happen before they actually do? And you take that into context with some of the breakthroughs that we're seeing right now around generative AI powered by large language models. I think that this was really the tipping point or the catalyst of where everyone across every industry took a step back and said, "Whoa, this is incredible."
Yeah.
The way we interact with data is completely fundamentally shifting. And a lot of this is through real time scalability. Right. So, I mean, these AI models that are now being integrated into SCADA systems, into IoT systems, this is what's allowing utilities to make these instant data driven decisions that have massive implications for reliability and efficiency. So for those who have been the quicker adopters to cloud are going to start seeing the value add across their organization, across their service territory and their customers a lot quicker. And I think we're going to see a much quicker adoption from others in the ecosystem that are still big early in their cloud adoption journey.
Okay. And like I mentioned already, it's been 10 years now since I said everyone was going to be all in on it. What challenges are unique to the power and utilities sector, when moving workloads to the cloud, which has kind of held them up to date?
Yeah, it's a great question, and it's something that I have a conversation with utility leaders around on a consistent and regular basis globally.
Hmm.
And when you look at some of the biggest challenges that have really inhibited the adoption of unlocking some of the capabilities of what cloud can do for the industry, I think it's really centered around regulation. And you can look at that from two perspectives. The first is the financial treatment of cloud investments. And we I mentioned earlier around the traditional utility business model, which really hasn't evolved, but the financial treatment or the financial aspects of cloud and the challenges around it really go back to a business model that hasn't evolved in even close to 100 years. And the cost of service business model, which is kind of how the traditional utility industry has operated, is it's based on something called a regulatory compact, where a utility earns a rate of return in exchange for the obligation to serve its customers. And that's traditionally how it's worked. All of the capital expenditures that are required to serve customers, so things like investments in infrastructure, transmission lines, substations, utilities have traditionally earned a rate of return on those investments. And the same was true for traditional technology licenses.
Hmm.
Utilities purchased those licenses, they were able to capitalize them, they were able to depreciate them over time and earn a rate of return on those investments as well. But now you have this completely different model that goes completely against the traditional utility model around capitalizing those investments. With cloud, and it's a subscription model, and utilities aren't able to capitalize a large portion of those investments. It typically hits their operational budgets or OPEX budgets,
Mhm.
and this disincentivizes the adoption of cloud, given that they fall outside of the rate base. So it's a big challenge. It's one that the industry is grappling with. We're seeing some evolution in the right direction, and we can geek out on some of the accounting standards around FASB accounting rules and IFRS and US GAAP accounting standards. But we are seeing things move into the right direction around regulatory reform. You're also seeing utility commissions change their position as well. The Alabama Public Utility Commission is a good example of regulatory reform, where they issued a directive which agreed to defer all the costs associated with cloud and capitalize them. The Idaho State Commission is another example of this. Still a long way to go, but I think the underlying message here is that often folks and leaders get we lose sight and get tunnel vision as to the obstacles of a cloud adoption. And what we leave on the table is that the real value or the business outcomes that we can achieve through cloud. There might be an incremental OPEX cost that we can't capitalize today,
Mhm.
but let's not lose sight of the business outcomes that we're bringing to the table for our customers, to our workforce, to reliability and sustainability. What does it mean to move these systems into the cloud? And what type of impact does it make to our critical infrastructure protection, for example?
Mhm.
Or how does this improve customer satisfaction and engagement? Or what type of productivity am I unlocking across the enterprise? I mean, these are the business outcomes and value that we need to stay focused in on, and not necessarily focus in on that, hey, this might not be able to be capitalized at this time.
Sure.
That's one major aspect. And the other aspect associated with regulation that's really kind of a challenge that the industry is grappling with is around navigating some of the NERC CIP standards, primarily in the North American market. These NERC CIP standards have been designed to safeguard our critical infrastructure from cyber threats.
Sure.
But interpreting and applying some of those standards in a cloud environment can be complex. There's a lot of nuance in terms of how these SIP standards were originally written. And a lot of those standards were written with the assumption that all of the infrastructure supporting the critical infrastructure around technology would be on premise.
Yeah.
So it's not always straightforward. There's a lot of gray areas that need careful consideration. There's some areas that NERC is very clear and very explicit, and there's other areas that are gray and that NERC leaves a lot to the asset owner or to the utility to define their own level of risk.
Sure.
So definitely an important topic. We could spend another whole session on this topic alone, but it's one that requires clarity. I encourage all of your listeners who want to dig deeper. We recently released an ebook that I had the pleasure of co-authoring along with Tom Ulrich around navigating NERC CIP compliance in the cloud and the options that exist today for what I'll say is majority of the workloads that can be deployed in the cloud today and ensuring compliance. While some areas we're still working on delivering some reform where we're actively involved in as well.
Okay. I'm glad you brought up cybersecurity and resilience as well. I'll park the cybersecurity for a second and I'll come back to it. But in terms of resilience, we know utilities are, with good reason, very risk averse. How does cloud migration impact the reliability and resilience of utilities?
Risk adverse is definitely something that the industry has grappled with, and rightfully so.
Yeah.
Right? It's the decisions that this industry makes has vast implications on across society, has vast implications on employee safety as well, health and safety. But risk at times can be used as an excuse not to take action,
Mm.
and to me that becomes the biggest risk of all. Right? Is we need to be doing things differently. We need to become smarter when assessing risk. But to your question around the real impact to reliability and resilience, you look at things like digital twins, and often can be considered a buzzword these days. But and also sophisticated AI models that can anticipate those failures. But there are things that we need to be putting in place that are going to deliver those higher levels of resilience and reliability. You look at what happened in Texas, right, just over a year ago with their winter storm. Massive, unprecedented event that led to the failure of multiple components of their energy infrastructure, left millions of people and businesses without power. And I think what that storm really did was it exposed how vulnerable our traditional energy system can be, especially in extreme weather. So, I mean, this really underscores how crucial something like accurate forecasting and capabilities are for renewable energy sources are required. And with some of the more sophisticated AI models, we can predict generation from wind, solar much better. We can, contextualize that with weather data, which is, weather's getting more and more unpredictable as we see in all parts of the globe. But how do we really balance energy generation with demand, which is what keeps the grid stable? And the answer to that is by using AI and cloud technologies together. A sudden drop in wind power or changes in solar, grid operators need to adjust in real time. This is what reduces risk. This is what reduces outages, especially when the weather throws you a curveball. And the other aspect to consider here is like you mentioned around cybersecurity. It used to be the biggest concern for power utility companies was a physical breakdown, a down transmission line, a faulty transformer, a relay that's not functioning the way it's supposed to. And now cyber threats are equally and just as serious, and some of the realities that exist today are quite alarming when it comes to the OT landscape in the energy sector. 39% of all critical infrastructure attacks are directed at the energy industry. And the impacts of this are profound. 60% of that result in some level of an operational disruption. Norsk Hydro experienced this firsthand. This is a case in point around how cyber threats can completely dilapidate the organization. At Norsk Hydro, that attack caused significant production stoppages. It's across 170 different plants and led to over $70 million worth of financial losses. So just, I mean, this is something that the industry is grappling with. A recent report that I read with the IEA, the International Energy Association, they reported that in 2022 alone, there were 1,100 cyber attacks each week on power utility companies globally.
Wow.
I mean, that is just, it's a massive number.
Yeah.
And that number is probably a lot higher as well. So, I mean, there's relentless pressure on our digital defense systems. And when you think about organizations like Microsoft, where we're investing billions of dollars to safeguard and secure cloud infrastructure, leveraging the most sophisticated threat detection signals. I don't think that there's this, not I don't think, there isn't a signal utility in the world that can invest to that extent to protect their on-premise infrastructure. So I think really looking at what do we need to unlock in terms of capabilities, and then how can we be better secure going forward. That's all of this kind of is wrapped around that resilience, reliability for the industry.
Okay, well, that makes sense. And so if I'm a utility company and I want to ensure cybersecurity and data privacy in the cloud, what strategies should I start deploying?
Yeah, and another fantastic question. And there's the way I like to frame this at times is that there really are kind of two realities today. There are those organizations that have been hacked, and there are those organizations that do not know that they are being hacked. So, some of the core aspects as to what utilities need to do from a cybersecurity perspective and data privacy. For one, ensuring that the entity, the power utility organization, is following the stringent regulatory frameworks. Need to comply with those strict standards, which often take into consideration like very comprehensive security controls, ongoing audits, and strict access management, and also looking at zero trust security architecture. A lot of utilities are beginning to adopt or have adopted some level of a zero trust security model, which really operates on the principle of never trust and always verify. And that approach really does take into account that every user, every device, and every application, whether inside the organization or outside the organization's network, is constantly and continuously authenticated before any type of access is granted to sensitive data. So I think that aspect is key. The other element is the industry needs to get super crisp when it comes to vendor management and establishing a shared responsibility model. This is something that is, I think, foundational. Having a clear understanding of what the cloud service provider's responsibilities end and where yours begin, and vice versa. That's critical to the future. And then some of the other elements are really getting better at the basics. Things like incident response and recovery planning, ensuring that you've got encryption and data protection aspects in place around protecting data that's in transit, at rest, and of course the people aspect, right? Regular security training, and ensuring that you've got the awareness programs built into the organization as well. People are often the weakest link in the security chain. So investing in cybersecurity training, investing in cybersecurity awareness for the entire workforce, ensuring that your workforce is aware of the latest cyber threats, phishing attacks and security best practices, for example. That human element is super critical, especially as most secure cloud systems that have been compromised through some level of social engineering or insider threats.
Right. Yeah. And in terms of, again, say I'm a utility and I'm thinking of moving some of my operations to the cloud, what are the workloads or applications that typically companies migrate to the cloud first?
Yeah, I think there's a lot of great narratives that we can look at from utilities globally around this, and I think what we've seen is Typically, utilities tend to focus on less mission critical workloads, in terms of your core OT solutions, but more on your IT side. Things like your CRMs, your billing, your core aspects of ERP and HR, supply chain, and majority of utilities have already passed this milestone, or
Mm,
continuing their journey there, especially when you consider Oracle and SAP, which are heavily used across utility companies globally. SAP Enterprise Central Components is going to be end of life by December 2027,
mm,
and S/4HANA is cloud native. So we're seeing those core aspects of the enterprise's digital core moving to cloud at an accelerated pace. But looking forward, the real opportunity and where we're seeing a fundamental shift is migrating those core operational or grid critical applications. And those are historically been considered too sensitive for the cloud.
right.
But we're seeing things like ADMS and DERM systems beginning to move to the cloud. These are those critical real-time grid management that balance supply and demand and integrate renewable energy sources as well. And an example of this that I can think of is the incredible work that we did in collaboration with Schneider Electric and PG&E and deploying really a first of a kind DERMS platform in the cloud, a real-time SCADA control system to manage DER assets and balance and shift power in real time, something that was considered, unlikely or very difficult to do in recent past. The other aspects that we're seeing more and more of a transition into cloud are things like your GIS systems, of course, AMI and outage management, and aspects of EAM, enterprise asset management. Our partners at IBM, for example, Maximo, or even our partners IFS, these are solutions that are the heart of a lot of utilities in terms of asset registries. And we're seeing these systems move to the cloud in order to unlock things like predictive maintenance, in order to ensure that we can take into account and enable real time analytics for modeling and really looking at reducing outages and improving reliability that's centered around cloud architecture. So tremendous shift, starting from IT across some of those core OT solutions, and then SCADA control systems, but there's still a lot of opportunity ahead of us to continue that path.
Super. And you mentioned renewables as well. How does cloud migration support the integration of renewable energy sources and smart grid technologies?
That's a fantastic question, and I think the way to look at that is really from a risk based approach. Something that utilities do often, looking at everything from a risk based approach. The IEA, International Energy Association, published their World Energy Outlook, which identifies some of the key risks that could delay or impede the deployment of some of the key technologies that are needed to support electrification globally. And in that report, it highly noted that there needs to be critical or sufficient policy support that are going to enable the right regulatory frameworks to ensure that we can have efficient, timely permitting and certification processes in place. We need to ensure that we've got robust and resilient supply chains, risks around skilled labor and workforce, that lengthy certification and permitting processes that slow the deployment of renewable assets onto the grid. You look at the wind industry, for example, there's over 3,000 gigawatts of clean power that's stuck in interconnection queues globally that haven't hit the grid yet. So, when we look at it from that approach, is how do we look at data? How do we look at cloud? And how do we look at sophisticated AI to address and mitigate those risks around workforce optimization, eliminating the drudgery out of operations, developing tactics around knowledge retention and collaboration within the workforce. At Microsoft, we're developing AI based solutions that are underpinned in the cloud to ease licensing and permitting for new nuclear, which can take years and years at a time. The other aspect is how do we support demand response and flexibility? And I think cloud is going to be a fundamental part of that.
Mm,
Being able to support demand response programs. Utilities are going to need to continue to expand around managing consumer demand more flexibly. So adjusting energy usage during those peak periods or when renewable energy is lower than expected. And the cloud enables that real-time communication between the grid and its consumers, whether it's through smart thermostats, your electric vehicles, you've got connected home devices, heat pumps. I mean, all of this is going to require a much more dynamic and flexible energy grid. And being able to predict and manage that demand, the peak demand, smooth out those consumption patterns and ensure that renewable energy is being used efficiently across the grid and we're getting the most out of every single electron that's being produced. And this has, when we think about grid stabilization,
Hmm.
huge opportunities. You have technologies like virtual power plants, VPPs,
Yeah.
where DER assets are aggregated and act as kind of that single energy source of truth. And all of this kind of cumulatively is what's delivering that resilient, adaptable, and forward-looking energy system. So really, it's a fundamental part of integrating DERs and smart grid technologies. The cloud is going to be underpinned throughout all of it.
Yeah. I love the idea of VPPs, virtual power plants. And when I explain virtual power plants to people in the technology sector, I say it's like cloud computing, but for energy generation.
I love that. Yeah, I love that.
So talk to me a bit about real-time monitoring and predictive analytics. Are they enhanced through the use of cloud?
Absolutely, absolutely. I mean, cloud is what enables that real-time data streaming and allows you to be scalable. I think it's one of the fundamental, one of the greatest advantages of cloud technology is the ability to process vast amounts of data in real time. And utilities are becoming more and more dependent. That dependence is going to continue to grow
Hmm.
around continuous streams of data, right? So I mean, I mentioned smart meters. You've got IoT devices, line sensors, PMUs, all these critical assets. And then you have real-time weather data coming from, satellite sources, all this to kind of continuing to monitor grid health and operational process. And there's a need to process and analyze that instantly. Right?
Sure.
This is what's going to unlock the ability to catch and identify where there might be anomalies on the grid. Things like sudden voltage drops or changes in telemetry. It's how you build in quicker responses and mitigate the chances of those potential outages. We mentioned digital twin and simulations and models that need to be used, and running those simulations and test scenarios is going to require a significant amount of real-time data processing. Being able to run a simulation, test different scenarios, assess the impact of, say, for example, external factors like a storm or a heat wave,
Hmm.
and assess that impact before it actually occurs. This is how you make informed decisions internally. It's how you allocate resources and ultimately optimize your asset performance. A great example of this is Eon, one of the leading utility companies globally that's based out of Germany. Now they have a need to inspect over, I think it was around 700,000 kilometers of power lines throughout Germany.
Right.
And much of what this team was historically doing was very manual, required a significant amount of effort. And they wanted to make this process much more efficient and use more of a digital approach to replace a lot of those manual inspections. And they introduced virtual inspections using drone images and building in AI models to develop a virtual inspection solution. And then they had to work with a number of different stakeholders and parties to do this. They collaborated with three different distribution system operators around this as well. But in essence, these AI models now analyze images. They sort and evaluate those images based on leveraging some of our key Azure services and determine where there might be anomalies or issues that need to be addressed instantly. All right. So,
Right.
I mean, this is all an example of where that predictive behavior can be, or the predictive element is driving significant value. The one other element that I'll mention here, because it's often lost in conversation when we're talking about predictive analytics, is how it extends to consumer behavior, right? Customer insights and energy efficiency.
Hmm.
Looking at energy usage patterns so that utilities can enable more personalized services to their consumers This is how we're going to tighten engagement and improve customer satisfaction within the utility industry. These AI models, many of which are repeatable. At Microsoft, we have something called our energy AI accelerators, where we've taken a lot of these commonalities and built common data models and common AI models that can be used and deployed with relative ease and quick deployments to drive, to accelerate that time to value. But in this context, looking at where customers are likely to experience higher energy consumption, being able to suggest energy efficiency programs or improvements that hold demand response participation within the ecosystem. And this has real dollar savings and impacts the pockets of customers. And it's what's going to help them reduce their bills and also help the utility balance energy loads during these peak periods and improve overall grid efficiency. So just incredible to see the kind of the progression and adoption here as well.
Okay. And what trends do you see in cloud adoption for utilities, particularly, with the increasing focus on sustainability and grid modernization?
You're talking to Microsoft. So of course, AI, absolutely, from what we're seeing across every industry and, putting that in the context of the power and utility industry, I think AI becomes part of the power utility industry's DNA going forward. I think it's going to be integrated, into all aspects of daily operations. We're seeing that trend today and it's picking up quite rapidly, especially as we're seeing these AI models become more explainable, more transparent, being able to leverage co-pilots, for example,
Mm,
which really act as the UI or user interface for AI. And we're also seeing the expansion of things like low code, no code platforms that are going to further democratize some of these AI models across all aspects of the utility business. We're going to see more of these AI applications deployed at the edge. So making much closer to where the data is actually being generated. And often I like to kind of paint a scenario for the workforce in terms of, how this AI trend is beginning to impact the workforce. You used to have, or you have, asset planners and reliability engineers who have to contextualize many different data sources together in order to determine system risk and asset risk when it comes to changing conditions on the grid. And some of that is very difficult to do in real time.
mm,
It's almost impossible in many scenarios. But, imagine coming into work and instead of poring over mountains of data and complex systems and just asking a question like, which assets have the highest likelihood of failure in the next 6 months in a particular region? Or what's the optimal time to buy and sell energy today? Or, are there any load transfer capabilities on the feeders impacted by the storm? I mean, this is the kind of help generative AI and co-pilots can provide, digging into your ERP, your ADMS, your DERMS, your EAM, all of your critical systems, analyze that data, provide actionable insights and really make a profound impact across operations. So really, as we're seeing this trend evolve, the question really becomes is where do we want to take cloud and AI next, right? It's to me across the industry, it's the possibilities are endless.
mhm.
Whether it's optimizing your capital work program, enhancing cybersecurity, improving demand side management, we're completely reshaping the entire utility landscape. And we're reshaping not just how we operate, but what's possible. Like I mentioned, imagine a grid or a world where grids are self healing. Where
Mm.
AI predicts an outage before it happens and is able to reroute power in real time. We're not talking about incremental improvements here. We're really talking about moving from that reactive to proactive. And the most exciting thing is that future exists today. These technologies are available to us today. We're not talking about something that's far fetched
Sure.
or a few years out. This is what's available to us today.
Cool. Cool. A quick left field question, Bilal. If you could have any celebrity or fictional character, alive or dead, as a spokesman for or spokesperson for cloud for utilities, who would it be and why?
Good question. And definitely a left field question. I like it. I'd probably say Iron Man.
Ah, nice.
Iron Man, Tony Stark. I think he's the perfect embodiment of innovation, bold decision making, leveraging cutting edge technology. Iron Man has the ability to solve complex problems with very futuristic technologies, and that I think aligns well with where we are with cloud platforms and Azure and generative AI and how it's reshaping the industry. And also he brings a certain level of charisma to his approaches around problem solving that I think would be a good thing to add in the utility industry or for any tech forward project, let's say.
Excellent. Excellent. We're coming towards the end of the podcast now, Bilal. Is there any question I did not ask that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to think about?
Yeah, absolutely. I mean, we talked about, and you mentioned this first around how the utility industry has a reputation of being a little risk adverse. And I think that there is a shift that we're seeing across the industry around culture and mindset. So maybe this isn't a question per se, but maybe a message in terms of or a final note as to how we need to continue to shift, not just looking at it from a technology perspective, but really that fundamental mindset shift that's required for the industry to remain competitive, to remain relevant, and really become the utility of the future. That comes down to growth mindset and culture, because we're in a way we're leading an internal revolution within our organizations because we're fundamental parts of the business. So to me, building alliances within your organization internally between business stakeholders and also alliances externally with partners like Microsoft, I think is becoming ever more important. And that hunt as a pack mentality, I think, is one that we need to have. It's a lot harder to do all this alone. It's best to have co-revolutionaries to really help drive this forward. And with that comes a premium on alignment, on collaboration. It's how we seed innovation. It's how we continue to grow and really build that test and learn mentality as well within our culture. Because like you mentioned, that element of risk is something that we experience and that we run into in our industry all day, especially in an industry that has been programmed to be risk adverse.
Mm,
I've been a victim of this myself on many occasions, given I'm coming from industry. But like I mentioned, a risk at times can really be used as an excuse not to take action, and that really becomes the biggest risk of all. So, really pushing your the shift in mindset and culture within the organization, I think, is going to be super critical to all of this around adopting cloud, adopting AI, and delivering the energy system of the future.
cool. Bilal, if people would like to know more about yourself or any of the topics we discussed on the video here today, where would you have me direct them?
Absolutely. If any of your listeners or viewers would like to reach out to me personally, feel free to contact me through my LinkedIn. We also have a tremendous amount of assets on our industry page for energy and resources at Microsoft, which have the NERC compliance ebook, which have a number of use cases that can be references around AI and cloud. But feel free to visit us at Microsoft.com and navigate to our industry page. Well, you'll find a tremendous amount of assets. Or if you'd like to have a conversation with me directly, feel free to reach out to me over LinkedIn. I'd be glad to have a conversation.
Tremendous. Bilal, it's been fascinating. Thanks a million for joining me today.
Thank you for having me, Tom. Take care.